Team 4065 Nerds of Prey. So a lot of teams have been asking how we managed to do this zone lineup using only one button. So to break it down, we take each of these polygons and put them as a zone. Essentially, the robot checks every single time what zone the robot is in. If it's in a certain zone, go to the predefined pose using the ASOR algorithm from the Pathfinder library. So the way we define zones is by polygons. Instead of the polygon is defined by a set of vertices. For example, these four polygons have five coordinate points, and these two trapezoids have four vertex coordinate points. You essentially use a simple form of the ray tracing algorithm to detect what zone the robot is in, or if it's in the zone or not. So for those who don't know, ray tracing is an algorithm used for 2D video games and 3D video games, mainly computer graphics, to render scenes, such as Minecraft rendering the terrain. So it shoots out infinite rays in all directions, or a finite amount of rays, and sees where the rays intersect and the distance. That way it can render things. In this case, we're only going to shoot one ray and in the horizontal direction. So the full code implementation by Team 4065 will be released at the end of the season, but we have coded up a Pygame demo. So this function takes in an x and y coordinate of the robot's current position, which comes from our geometry, and a polygon. Again, a polygon is defined by vertex points. So for example, zone 1 field is a polygon, and it has five vertex points to define that polygon. So we take a Boolean we initialize as false. We have a variable called n, which is the amount of vertices, and j is equals n minus 1. Essentially, we want to iterate over every single edge and do our horizontal ray detection algorithm. So we iterate over the amount of edges we have, and then we store the first vertex, and we also store the last vertex. And this if statement basically checks if my horizontal ray has intersected a if it has intersected a edge. So first checks if my robot's y coordinate is between the two y values of my current vertex and the previous iteration's vertex. And this computes the exact y coordinate there. The uh, the horizontal ray intersects with the edge of the polygon. And if that value is less than my x value, my current x value, then it the inside equals not inside will stay up at that state. Essentially, for example, we go through this vertex here, this edge over here. This will equal false if statement won't run because the y value is not between these two values. The y values are the same. But if you go on this edge, the value is the same. If the robot is here, then it will count true. This will the statement inside will flip from false to true. When you go to this edge, that won't happen. This edge, that won't happen. This edge, that won't happen. It won't flip the state, so it returns true. Same thing for here, and same thing for here. So I've coded up a Pygame demo, which the Team 4560 will release. Link in the description or comments. Essentially, for visualization purposes, it's shooting rays in all directions, but it's only checking the horizontal and x coordinates. And I will do a simple demo, simpler visualization. You can see that we shoot an array in the right direction, but if I'm see we compute the y, right? And if I'm not in it, we first compute the y. The y coordinate of the robot, the green represents the robot, is between the two edges we're detecting, and then we shoot a ray to the right to detect if it's in the zone or not. So of course we found the x coordinate of the point of intersection, and our current robot's x coordinate is less than this x coordinate. That's what's considered inside the zone. But if I'm outside, it won't happen. See now these are two intersection points. Since inside not equal inside flips, this will go from false to true to false. And The way this algorithm is very versatile. It's very simpler. We don't need to run full-blown ray tracing algorithm because we're running this on a RoboRio. And you can check a lot of zones. In our code, we check if the robot is in each zone or not. We run this function iteratively for all 6 zones in this case. And this algorithm is simplified here. For example, this is zone 5, zone 6, zone 1. You can see the state changes, but if I'm in, no, not in any zones, it doesn't change. Hope that helped.